Hi guys, this is Abdurrahman Gilal. In this video, I'll be trying to explain the fundamental parts of computer and the fundamental concepts of Java, that how it makes the program. So what is program and all those things I'll be explaining shortly. But when I say word computer, what comes in your mind? Usually, when we think of computer, we think of hardware and software, and it is not wrong to say that a computer has, different parts to be a complete system. So hardware is one of the important parts of the computer. So all the physical or tangible parts considered to be hardware. For example, the mouse, the keyboard, the screen, anything that we can see and touch, definitely that is called to be hardware. But what is software? I would say anything that helps us to run the hardware can be called software. Anything that helps us to can interconnect the hardware with the user, it's also the software. Anything that basically receives the data from the user and provides to the hardware of the computer can be the software as well. So software is a big definition. So usually different answers have different definitions in order to say like computer system is composed of hardware and the software and data, I would say. And then we have user as also a very important part of the computer. So user can be human, user can be computer itself. So these are the four important parts in my opinion, that if I say if computer systems. So in order to, have a complete system, we cannot eliminate any of them. But now, as we know that we are learning programming in this course, so I would be saying then how I can basically use programming anywhere. So basically, if I see the definition of software, it includes programs as per Walter Savage, which means in order to run the hardware, in order to collect the data from user, or interact between the hardware and user, create the interaction between the hardware and user, we need software. Software is collection of programs, if I say it's not wrong, right? So when I say programs, basically I'm saying in order to develop the program, I have to learn programming languages. So what is programming languages? Programming languages are the languages those helps us to develop a program in simple words. So now, do we have one type of programming languages or one programming languages? The answer is no, because definitely we have different type of software. So for instance, we have different category of software. If I make it like this way, that we have system software, and if I say application software. So it's a big category. So nothing wrong if I say system software is a software or program that basically is supporting the parts of system. For example, if I say operating system, it's also a software or program, which is the superior program, but that only controls the parts of computer and manage the memory, manage the instruction set, and most of the things that basically as the super monitor of everything. So that's very much right. If I say drivers for the mouse or the keyboard, nothing wrong to say these are the system software, because system part has having hardware. But if I say I am using Microsoft Office, it's an application software. If I say I'm using Zoom, it's basically application software. If I am saying I am playing a game like FIFA game, it's an application software, because this is helping me to play the entertainment over the system. So if I am developing FIFA, I will have to use different programming language, because FIFA is developed on a different level. And if I am developing operating system, I have to use a different programming language, because I know that operating system is very close to the hardware of the system. So, so different programming languages has different purposes. I will be discussing it later in different video, but in this video, I'll be just quickly explaining that how the overall system works together. So basically, when I see this information processing cycle, we provide the data to the computer, and then the computer processes it and it gives us the information. That's a very basic definition of information processing cycle, that the user provides data and that goes for processing and then goes out for the information. And sometimes we store the data. So there are two types of memories. One is called sorry about that. One is called, primary memory. Another one is called auxiliary memory or secondary memory. It's all okay. So when I say primary memory, which I'm basically trying to say that anything that is very close to the processor, because processor is the central point of processing any request that comes. Either it's a system request or it's the application request. So anything that basically is providing space to the processor, that's called the main memory. Sometimes it's also called random access memory. So let's be quick about this because I know that's very fundamental concepts that you might have heard. Okay, so when we have a processor, so processor has the processes of programs instructions. So basically operating system is one of the example. So let's see like how Walter Savage has explained it. So main memory is basically, works on bytes because it has random access memory. As I told you, then 8 GB. So it's a space, that overall space. So how Walter Savage is explaining it, it's saying is that, for instance, usually the information that is being processed is zeros or ones, or it's a bit memory. So the bit is a very smallest unit of information that can be stored, either 0 or 1. But one bit does not have address, so only a byte has an address. So 8 bits collectively make 1 byte. So usually when we are working on any programming language, we can interact with the bytes, but we cannot interact with the bits because byte has an address, but bits does not have address. So this is how it looks like vertically or horizontally. That, for example, byte address 3021, that's an address. And this is the byte, for example, whatever value could be the composition of bits. So it makes some sense. I will be explaining you when we start doing coding. I'll explain you that how the representation of these bits combinedly make the bytes, but combinedly make information. So we will be discussing it a bit later. So let's quickly run and see like if we are trying to talk about auxiliary memory or storage. So we are trying to talk that CDs, DVDs, flash drives, or anywhere we keep the data for longer run, not for the shorter term or for the time being. So it's like a permanent one. So that's why we call like it's non-volatile. So basically different people has different ways by which they interact with the memory terms. But I would say that whenever we store things for the longer run, we basically say that we are trying to talk about files. So files are the places where we store the programs or data or information for longer run. That's why our operating system is also working on file allocation system or tables. So if FAT, so that's how operating system works behind the scene. Okay, so now let's quickly jump on the programs because we are going to work on programming languages or especially Java. So I would say like a program is a set of instruction for a computer to follow. So it's just a simple thing that, as I told you, that it could be instructions for the computer itself, or it could be instruction for a computer to entertain the user, so anybody who's using it. So we encounter like a bank ATM, mobile phone software such as WhatsApp or anything that is there for us to, run and work. How do they work? We have a central processing unit, as I explained you right up there, that this one, this central processing unit, as Walter Savage has explained, this point is basically the point where everything is executing. So here we provide the data and then central processing unit processes it and takes the information out. But that's not sufficient for us to make a decision here. Why? Because I'm going to tell you, Walter Savage also explains that it's not sufficient to just provide the data, but we have to provide the program as well. As I told you, for example, I'm giving some information to chat with my friends. So which software actually I'm going to use for the chat? Am I using Snapchat or am I using WhatsApp? So what program basically I wanted to load into the computer processor, and then what data I'm going to provide, because as I told you, without data, it's not possible to run the program as well. So the data and program goes combinedly into the computer, center, and then it provides the output. That's how it looks like. So now things happen. Sometimes the program are, written in high level programming language, and they are not easy for computer to understand. Well, so what's high level, what's low level? I explained you shortly like this, that for example, that anything that we are working is very easy to a computer to understand. That's what we call low level, because it's very close to the processor. For example, if I say machine language or assembly language, so that language is very close to the processor. Processor understands everything that it says. It helps the translation of of information into bits or bytes, so that processor quickly it understands it. But the high level languages are those languages which are having some human closeness keywords. For instance, if I am using English, so it's English is having some common words that high-level languages may have. For instance, if I'm working on Java or Visual Basics, I can use some keywords such as print or read or write. So these things human can easily understand, but not easily understandable by the a computer, because computer does not understand directly. So what happens actually? So there comes a bridge. It's easy for human to work over those languages, so but it's not easy for computer to understand. So let me draw a scenario. So this is the processor CPU, and CPU is working over assembly language. Let's say the assembly language, and then assembly language is a low level language, but we are working on a high level language, which is, for example, Java, let's say. So now Java is easy for a human to understand, because that is having some keywords which are easily understandable by human. But now the CPU is not directly understanding it, because there's a high level language. So what happens? So we bring a translator in between, and that translator can be called as a compiler that helps us to translate what Java program says. So this one converts the program into the low-level language. So the compiler is the translator that holistically convert the high-level program into the low-level program. So that's how it works. So Walter Savage has explained in a better way. Let me explain it further. Okay, so compiler translates a program from high-level language to low-level language, but compiler, so any program, for example, if you're working on a Java language, if you're writing a Java code, any code that is written is easily understandable by us, because we are writing it, but not easily understandable by the machine or assembly language, for instance. So the compiler will help us to change the source code into a way by which compiler can instruct the hardware. So compiler basically does not directly convert the code into the machine readable, but in Java, compiler converts the code into the byte code. So what happens to the byte code? Let me show you this. Yeah. So what happens that the byte code is the machine language that machine understands. So byte code can easily be now interpreted. So interpreter is also kind of how to say, kind of a translator, as compiler is a translator, but it brings directly to the execution of the code. So if I say, let me see, if I have a CPU, and if I have high level language such as Java, for example, and then compiler, if compiler directly converts, if I'm not saying to the CPU language. But now, which company CPU are you talking about? Are you talking about Intel, or are you talking about Mac or Apple? So I don't know which one are we talking about. Maybe there can be more company, Motorola or something. So that's gonna be once again a big challenge. So if we have another compiler for, oh sorry, CPU, such as like I'm working on Intel, so compiler has already converted to Intel. So if I have Mac, so now compiler has to change for the Mac. So it's gonna be very difficult. So that's why compiler does one thing good. It converts into the bytecode. When it converts into the bytecode, now bytecode is a machine readable thing. So now if you have a JVM anywhere, JVM means Java Virtual Machine. So Java Virtual Machine. If you have JVM anywhere, that's called hypothetical computer or interpreter, that will simply translate it to any machine. For example, if we have CPU of Mac or any other product, or any other company, it will be easy for them to be how to say, translated. That's why we say the bytecode is machine independent. That means it does not basically rely on any particular software or any particular machine. These are just an examples I'm trying to give. So I don't have to be saying that this is just a way that it works, but it is just an example that we have to understand in a better way. So okay, let's go further. Let's see how it helps us. So basically, once again, I say we write the source code. What is source code? Give me a second. Yeah, we write the source code. The source code. So anything in order to write the program, we basically write the source code. So code is the source code means the place where actual code is stored. So code means the programming code. For example, this is my Java source code. It should be in some files, right? And then what we do is that we use some compiler or compiling, and then the compiler converts into the bytecode. Bytecode then will be interpreted by the JVM, and then it will be running. So JVM is my example here. So JVM is Java Virtual Machine, and then bytecode is, so compiling will give us bytecode, interpreting is done by JVM, and then JVM is basically running the code. So this is how it looks like. Don't worry about these instructions, Java C command, because we're gonna use some IDE. So you can use Eclipse or IntelliJ when we learn this, how to code. But for the time being, just don't worry about this. And one of the beautiful thing, as I told you, that the bytecode is machine independent, so you can keep the program anywhere in the world, over internet, over hardware, sorry, on desktop or anywhere. It's easily possible. So that's what we call the portability. This is one of the advantages of using, Java. Excuse me. So sometimes the word class loader here is very easy to say that when I say language is not possible without few things, without vocabulary and without the set of rules. For example, if I say I eat a mango, so I is a word, eat is a word, mango is a word. And the rule is subject has to come first, then verb, then object. But how about like if I say eat mango I, it does not make any sense because it violates the rules. So two things are making language. One is set of rules and vocabulary. So in any programming languages these days, especially high-level programming languages, we have been given a lot of vocabulary, a lot of rules, and a lot of developed things available for us to just work over them. So what we happens that we have certain things available provided by the language itself, provided by the developers of language, or provided by some other programmers for us to just simply use them. So when we are using them, for example, I'm just trying to, print something, or I'm trying to save something. So saver is there. So what am I going to save? This could be my property of the file. So that different parts of the system, which are developed or which are your developed or pre-developed. So I'm going to say like this, just for the basic understanding. So this is my program. My program is to play a song. play a song, right? So I am going to play a song. So the song will be played on the speakers, definitely. So speaker has a software, definitely has a software. And I have certain instructions which I will be passing it to my computer, and computer will be then helping me to play here, right? So now the things happen in this way that I will have to load something here which are predefined. The what am I supposed to do through this? So when I'm loading, which means I have already developed some matters. So that loading will basically done with the help of compiler, or sorry, with the help of class loader, because there are so many things that are there in order to complete one, for example, program. So when we have different units of program and they are going to work collectively, that's what we call this as now we are trying to, loading a complete program. So in some programming languages called linker, in Java, you can call it loader. It's up to you. So let's say a Java program typically consists of several pieces called classes. So you may have what is class. I will be discussing in another video, but let's say different units. For example, a vehicle may have one vehicle, have wheels, steering, some doors, some windows. So how many things are there that are collectively making vehicles? So each of them can be considered as a class. So if each of them is considered to be class, so now you are trying to make a vehicle, complete one. So now you have to connect them. When you're connecting them, so Java basically has different types of bytecodes. So the class loader will combine them. That is how it works basically, if I say in a bigger spectrum. But as soon as we start writing code, you will understand better for sure. So how a complete shape looks like. So it looks like very simpler. If you see here, so first of all, you have to have your own source code. So this is my source code. So this is my source code, for example, or program. And then you have to provide data. That's what we discuss. So when you have a source code, so Java compiler will convert into the bytecode, and then bytecode is not executable without JVM. So JVM is basically bytecode interpreter. So that will instruct the machine language instructions. So now those instructions now are executable. Based on what? So we have to provide some data. So once we have data plus instructions, so this makes a complete output of the program. So I hope it makes some sense. But if you have any question or confusion, please do not hesitate to drop me the message. Thank you so much.